Welcome to the Interop. My guest today is Anurag Arjun. He's the co-founder at Avail. They're a data availability layer for modern blockchains. In today's conversation, we will discuss the Avail genesis story and how it spun out of Polygon. We'll dive into the different components of the modular stack and the emerging ecosystem of teams in the modular space. We'll look at Avail's architecture, what makes it unique. We'll also get into data availability sampling, seeing how that works, and talking about the economics and tokenomics of the platform. I'm also dying to find out why he thinks app chains are making their way into Ethereum and threatening EVM dominance. Before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified of new episodes every week. And remember that none of what we discuss on the Interop is investment advice. And if you enjoyed this content, please consider sticking with us. We're live on Evmos, Quicksilver, Osmosis, Juno, and Nolus. Just look for Interop in the active set. My guest, Anurag, is coming up next, right here on the Interop.
Hey everyone, hi Seb. Thanks for having me on the podcast, and really looking forward to this discussion. Quick introduction. My name is Anurag. I'm co-founder of Avail. Avail is a new kind of layer one blockchain that focuses on providing data availability to rollups on top. Primarily over the last 2-3 years, what we have seen is this dominance of the rollup execution paradigm, with execution moving from the base layer to the layer on top, and this we've seen primarily on Ethereum. But what these rollups really require is tons of data availability, and so that's kind of the purpose with which we started Avail back in late 2020. Just to give some context on the initiation story, I co-founded Polygon, or Matic it was back then in 2017. That's actually when I entered the crypto space. Before that, I was a more fintech, regtech kind of a guy. So this, after we kind of launched Polygon POS back in 2020, mid 2020, that was when we were kind of looking for what to do next on the Polygon roadmap. And so we had execution on our mind, and data availability as well, in the sense that Matic really started out as a plasma scaling solution, which was primarily an off-chain execution and off-chain data availability solution. Of course, Plasma never got implemented, but we pivoted to POS first, and then we knew that POS was not going to be a long-lasting solution. So that's why we pivoted to ZK rollups on the execution side and data availability on the Avail side. And so that's where really the Avail really came from, this understanding that rollups are going to be the future, and that these rollups will increasingly need and the scalable data availability layer, because rollups are very data hungry, and you really need a base layer that is specifically designed for that. In contrast, Ethereum really began life as a more execution focused chain and is now pivoting to data availability. And so that's why really Avail really came through. We've been working on Avail since the last 2.5-3 years now, and in March earlier this year, we kind of spun it out of Polygon, and it's now its own separate independent entity with its own team. We have actually now grown pretty fast. Like when we spun out, we were 20 people strong, 18, 20 people strong, and now we are actually up to 40. Mostly which are engineers, but we are, growing the team as sustainably as possible.
Yeah, that's really impressive that you were able to sort of spin it out and grow the team to such a large number. Like when you were working on Avail, when you were still at Polygon before it was spun out, like were there areas where you felt like the Polygon vision was falling short and you felt like Avail could solve some of the issues there, or was it just sort of an ideological split about how to scale blockchains? Because Polygon has now gone this whole ZK route for scaling and building rollups. and I mean that's a very different approach to the data availability approach. So yeah, what's the chasm there that like caused Avail to want to like go in a different direction?
Yeah, so unfortunately, or fortunately, like we didn't have much of a, like a rift or a chasm in the literal sense. Mostly it was primarily because, like if you kind of look back at Polygon's product suite, right? Like it's pretty wide. So at that point in time we have had like a Polygon POS, but we also had like a Polygon Hermes ZK EVM, a Polygon Zero solution, Polygon Maiden solution, of course Polygon Avail. Then you also have Polygon ID, like Polygon Nightfall. So it's just two super nets at some point in time. So it was just a very wide product suite. And Polygon, of course, is a big player in this space in general, but like any organization that has to handle these many products will not be able to do justice to each product on its like standalone, right? Like so, it was becoming difficult to juggle these two kind of narratives within the same organization, in the sense that the more recent ZK EVM or Polygon 2.0 initiative is more Ethereum L2 specific, right? Like so Polygon is going strong on that brand, right? Like Ethereum being an leading Ethereum layer two player, right? Like I mean ZK rollups on Ethereum, and that was not fitting in well with what Avail really wants to do from a layer one perspective. Because and so the identities are pretty different. The product is very different. The positioning is very different, and so it's very difficult to able to manage this within the same organization. And so we thought it was best to kind of spin out and do this separately. It also allows us to kind of allocate resources accordingly, right? Like so I would say it was more a resource alignment move rather than I would say like a rift in the literal sense.
Okay, got it. Yeah, let's talk a little bit about the different types of security layers or DA layers that applications can use. So, there is this data sampling DA narrative that I think Celestia has been sort of carrying, and Avail definitely falls within that category. Then we have like restaking, like EigenLayer, and I think we could also put Cosmos interchain security in that bucket. And then we have Ethereum. Now, Ethereum can do data availability, but it can also do like on chain transactions and sort of on chain contracts. Yeah, how do you think? How should developers be thinking about the different trade offs when choosing their data availability and to some extent, consensus layer for their application, right? If you're an application developer, you're looking at whether you're going to be building on the EVM or Solana VM or Cosmos SDK or any number of like different execution environments. When it comes to choosing the security layer, like what's the biggest thing that people should be considering? What are the trade-offs that they should be thinking about, etc.?
Mhm. No, I think that's a great question in general. So I'll try to break this down into couple of segments in the sense from a developer point of view, right? Like I mean, there are two developers that we can talk about here. So these are, of course, there are application developers out there, but there are also these more, like roll-up developers out there, or chain developers as we might call them, right? Like, and so the choice of data availability firstly goes to the chain developer or the roll-up developer. The application developer comes later in terms of because they have a set of different trade-offs to make. So I just start from the roll-up developer first and then go to the application developers. For the roll-up
Sure.
developer or for the chain developer, right? Like I mean, if you're spinning up a new chain, right? Like what do you have to do, right? Like so let's say you're a new team or developer who want to spin up a, let's say, a Cosmos chain, for example, or any sort of chain, right? Like I mean, what are the steps that they need to do, right? Like they need to, of course, spin up the software using something like, let's say, Cosmos SDK, or like, let's say, like Geth, for example, or even like Polkadot SDK, or something like that, some framework. And then in the case of Cosmos or like an independent L1, they need to bootstrap this set of validators, for example, and so on, right? Like they have to do a token. So that they have to do a community, ensure that the token does well, ensure validators are incentivized, and so on, right? Like, so there's this whole cost of creating a chain in itself, right? Like, and um, that gets kind of solved in a way by way of like shared security in terms of the roll-up paradigm. So now let's say like a base, for example, right, can be spun up by Coinbase, for example, pretty rapidly without getting into this whole validator bootstrapping problem, right? Like if you look at Base, they took the OP stack and then just deployed it as a roll-up on Ethereum. And essentially, the entire work around bootstrapping the validator set and ensuring that the chain inherits security, for example, that goes away, and chain developers can now really focus on GTM side of activities, right? Like, so Base is what Base really got from the OP stack and being a rollup is that they didn't have to invent or create their own security. They just inherited the security from the base layer, and now they can do stuff like friend tech, like basically GTM activities, right? Like, so I would say from a chain developer point of view, the rollup shift to rollups is the main thing. And from that perspective, right, like if you want to do a rollup, it's a question of shared security. Now, what is the level of security that you want to inherit, for example, and that will depend upon like a lot of trade-offs between cost, the user experience and such, for example, right? Like, so if you are maybe like a stable coin DeFi sort of application that like really needs today Ethereum security, for example, you would like do a roll up on Ethereum, for example. But as we are seeing with players like Arbitrum and Starkware, for example, which employ solutions like Arbitrum AnyTrust or Starkware Validiums, for example. All of those are, like choosing data availability layers which are different from Ethereum, right? Like, so currently those might be DACs, but, like once like solutions like Avail and Celestia come into production, like you'll increasingly see the usage of these layers. So just to quickly summarize, right? Like, for chain developers, this is a very credible alternative to kind of building a sort of independent chain. Um, Again, it's a complex, nuanced question, right? Like, I mean, do you want to control your cryptographic security, or do you want to get into the shared security paradigm, right? Like, it's a question, and it's all right to like be a more sovereign, independent kind of chain like the Cosmos chains are, like so. So I was like asking this question at Cosmos was actually, and like let's say a certain Cosmos chain has probably, let's say, 500 million in security, for example. So does it make sense for them to move into a shared security context if they are maybe securing 200 million of TVL, for example? So maybe not, like in that case. But if it is approaching 400 million of TVL or 500 million of TVL, so then they may want to increase security or share the security from another base layer, right? Like, and that might be Ethereum, it could be Bitcoin, but like entirely something else like Avail, for example. Once Avail also like gets that kind of crypto economic security, so it's a complex, nuanced questions. But like those abstractions will like become, it'll be more abstracted as we go forward. Right now we are at the very early infrastructure building stage of like this separate layers of blockchains. And quickly, like getting to the application developer point of view, I think for the application developer, things are also changing pretty rapidly with this emergence of like ZK systems, right? Like, so there are two primary things that we have to keep in mind, right? Like, one is like you have execution, then you have like consensus and ordering layers. Now, because we have these newer ZK execution environments, like validity checking is actually becoming very, very powerful, in the sense that like even if you have like a single prover and that can provide a mathematical proof, you can prove execution validity. Now, so basically in that context, what really matters then is like the ordering or consensus or the fork choice on the base layer. And so it's basically what is happening is it's now becoming much and much easier from a from this perspective to actually come up with arbitrary execution environments, right? Like, so it's not only like a EVM environment or a like an ABCA environment. We are seeing like move environments, for example, like newer custom environments like let's say there's a team called Polyline that is building on Maiden VM, for example, that has brought out a new kind of experience. Uh, People are taking the Mina VM and like doing a roll up runtime on top of it, for example. Sovereign Labs is doing a new kind of execution environment using RISC Zero, for example. So you have these newer kind of execution environments, and I'm seeing a definite focus on more application specific roll up execution environments. And I think that will become much important in the future, right? Like, I mean, not everything really has to be on a shared chain. Like, not everything needs to be on the EVM, for example. And so, for application developers, as long as once the correct abstractions is in place, it'll be more of choosing the right tool for the right activity, and then because you will have access to other applications using some sort of interoperability and so on, right? Like, so essentially it'll be at some point in time it'll be more like like write your program, and with the emergence of ZK it will get proven, for example, and then it's just about consensus and ordering.
Yeah.
Yeah.
So what about like you were talking? We said earlier that you thought that app chains were making their way into Ethereum, and that essentially the app chain model. I mean, I kind of facetiously said threatening, but that the app chain model was in some ways for some applications probably better than using the VM. It So it feels to me like basically app chains wanted to app chains promised execution sovereignty and security sovereignty and like sovereignty over governance and things like that. But it turns out that the thing that people really want, or that the thing that is better for applications, is execution sovereignty. In that, in a DA world, security sovereignty matters less, and governance sovereignty. I mean, you could still have governance sovereignty with an application chain. So, do you think that like the EVM rollups, of which there are many, right, where you deploy smart contracts on an EVM, do you think that those have long-term viability, or new applications would rather just spin up their own VM, like their own Cosmos SDK rollup or Substrate rollup or whatever rollup, so that they have full sovereignty over execution, over governance, perhaps over settlement as well if there's settlement rollup? Do you think that we're heading in that direction, rather than just like more shared execution in the form of EVM rollups?
Yeah, I mean, I think so. There are many answers to this, but I'll just maybe try to illustrate this with an example, right? Like, I mean, from an application developer experience point of view, right? Like, so when you are building an application for the EVM, and at my time with Polygon POS, for example, I've interacted with like maybe hundreds and thousands of developers, right? Like, and like this, there was this, like, let's say someone like a major enterprise wanted to add NFTs to their app at that point in time, for example. And so if you kind of try to understand the development methodology that they have to follow, right? Like, so if you want to add a simple thing like an NFT to existing app, right? Like, I mean, they have to run an EVM indexer, which is not that easy to set up, right? Like, either you write your own indexer, or like take up a subscription from a hosted one, for example, right? Like, and then you have to manually parse your logs, because the EVM is a shared state model, and you have to like map your data model to the EVM's data model, and then parse the logs, like listen to every block, parse the logs, for example, and so on for your own app data. Like, you have to run things like like hosted full nodes, like you have to have an Infura Alchemy, for example, subscription. Some of these can be pretty expensive at some point. you also have to run transaction relay infrastructure, like let's say Bioeconomy or something like that, right? Like just to ensure your transaction gets confirmed, for example, or retry or those kind of things, right? Like so, what I'm trying to illustrate is it doesn't seem like it, but there's actually a lot of infrastructure overhead that a normal application developer has to go through just to run something as simple as an NFT application, right? Like and that has been the refrain for a lot of application developers, that we end up doing all this infra overhead time, and so it's again it just takes away bandwidth from the most important part, which is the business logic of the application or the creative part of the application, right? Like and so I mean, of course there are other points, but like even just this point, like of course you get access to, let's say, synchronous composability and so on, right? Like, but I would argue that a lot of this thing is possible in a more application or execution sovereignty model with like interoperability between these environment, right? Like um, and so I would certainly say the overhead in terms of creating these more app rollups, for example, will actually tend much lower over time, right? Like, I mean, today, like doing an Cosmos SDK chain still is a lot of work. Doing an application specific rollup is still, like very much early. But I think in the next 6 to 12 months, you will see that, like you will have frameworks where spinning up an app chain is like, like a one click thing where all the infra is taken care of, and you no longer have these like these kind of problems, right? Like, I mean, getting your transaction confirmed, or like doing a shared RPC, or doing this big indexing thing, because like so it's all of this become easier in a more execution sovereign kind of like world, right? Like, and so I think you put it very rightly, right? Like, there's an execution sovereignty thing, there's a security sovereignty thing. The security sovereignty thing has proved to be notoriously difficult to bootstrap and maintain. Uh, and so I think the main benefits of that is on the execution sovereignty side. And this move towards app rollups specifically tends on the execution sovereignty side.
Yeah, yeah, I tend to agree with that. I think like for like Dimension is one example, right, of a team that's building this kind of like roll up as a service, or enabling easier roll, like making it easier for rollups to be deployed to underlying security layers. So like I think that's a step in the right direction. And I mean, look, it makes sense if you compare it to the like application paradigm in Web 2. We moved away from like shared hosting or like shared execution environments a long time ago, and now everything is a container, everything is contained, and execution is sovereign from the point of view of the application, to the point now where even like functions are now their own execution environments, right? So like things have modularized in that way, and I think that the EVM model doesn't really align with that. Now the thing, I mean, like the EVM has like tons of developers, tons of network effect, and like people who build on the EVM, I think I mean, for people that I talk to who build on the EVM, I think they feel like EVM dominance is here to stay, but I don't know how that aligns with just the sort of like natural progression of how applications are modularizing, and how they did in Web 2, and I think like how it's inevitable in Web 3. So, but yeah, I want to get into to Avail a bit more, and talking about the architecture and the different components of the stack. So yeah, what are the different components of Avail, and like different components of the stack? And one question that came up when I was asking on Twitter for question is why you chose to build on Substrate, and yeah, what was the motivation there? And then we can get into other things like consensus and the proving system and data sampling and all that.
Yeah, no, makes sense. So quickly, I'll give you like an overview of the Avail architecture, and then I can get to the substrate question specifically. So the architecture itself is that like actually there we build or maintain two networks actually. So there is this base layer validator run network, which we call the Avail base layer, and then there is a separate light client data availability sampling light client network, which itself is a network in itself because like all the participants have a P2P layer in between, and then the light client network talks to the Avail base layer in that sense, right? Like so essentially, like Avail is comprised of these two different networks which are connected to each other. The base layer itself is built off substrate. So we when we were starting out, we had this a choice to like what framework to base our development on, and so of course the choices were Tendermint and Substrate at that point in time, right? Like, and we had previously used Tendermint at Polygon POS while building Polygon POS, and so we had extensive experience using like Tendermint for there. And Substrate was maybe a couple of years into development at that point in time, and like when we started looking into it in 2020, it was surprisingly like well done, well engineered, modular in the like in the real sense. In the sense, it's very easy to actually switch off or change some functionality without like disturbing the whole code base. For example, it was
Yeah, I
written
think they
in
were very
Rust.
early to like building a very modular development stack. Like even like in 2019 and or even earlier, they were quite early to building like this very modular stack. Yeah.
Yeah, yeah, yeah. It's also like like our tech stack is primarily Rust, so it was like great that like it was written in Rust, for example. And also like from what we got out of the box from Substrate was also like Grandpa and Babe consensus. This is like not maybe well known outside of the Polkadot ecosystem, but it's like really like well written in that sense. Grandpa Babe consensus is like a hybrid ledger, which Babe does block production and Grandpa is responsible for finality. So it's like a hybrid ledger where you kind of maintain block production via Babe, and then there's this finality gadget on top from Grandpa. And so it's possible to like for the chain to keep running, and then finality can be reached later in extreme circumstances. Mostly finality is reached within a couple of blocks, but in general, in terms of network partitioning and those kind of like edge cases, you can always do a delayed finality. And so it's basically like I would say in the direction of like things like Gasper on Ethereum, for example, in that sense. So it's slightly different from, let's say, Tendermint, which has this instant finality thing. So different characteristics, right? Like I mean, Tendermint will halt if there's a like a problem there in that sense. So I mean, of course, there are pros and cons, etc. For example. Then I think we also were we are able to onboard like support about up to 1,000 validators with Grandpa consensus, and that was attractive to us because we will be able to support a bigger validator set than let's say on Tendermint, for example. And one of the very underrated things from Substrate is this NPOS or nominated proof of stake system, which essentially, like so it employs this implementation of something called fragment, which ensures that you have stake distribution. When people nominate or delegate their tokens, it doesn't go to a single validator, unlike in like Tendermint or Cosmos POS, for example, right? Like so, it kind of ensures in protocol that the stake is roughly the same across the entire validator set. So it ensures that like we have good stake distribution mechanics. And this was actually a big problem for us while we were building Polygon POS. Like even today it's a problem, and we try to address it with a variety of mechanisms, not necessarily in protocol but also off protocol. But the reality is that on Polygon POS and in most Cosmos chains also, which use Tendermint POS, eight, six or eight of the top validators really control more than 67% of the stake, which is a problem that we would rather avoid. So because essentially what we envision is Avail to be like the base layer for a lot of rollups on top, and we want this to be really decentralized. And so we started with the foundational tools required to make that happen, essentially. So I mean, it's a combination of all these reasons, but yeah, that's
Yeah, I mean
kind of.
that's interesting. Let's talk a little bit more about the consensus. I think this is like I don't like to I don't want to like compare Avail to Celestia so much, but I think like one of the main differences, at least, and I think there's two kind of main differences if you kind of like look at both protocols side by side. Is one is the proving system, where Avail uses validity proofs while Celestia uses fraud proofs, and then the other is the consensus. And I think this is sort of similar to the way Cosmos and Ethereum are different in consensus. Ethereum can scale to many hundreds or even thousands of developers or to validators, but have probabilistic finality. Now that's a trade-off that Ethereum makes because it wants to be fully decentralized, as decentralized as possible, with as many validators as possible. And Cosmos has this instant finality, but Tendermint consensus does not allow. Basically, it starts to fail like once you get into the close to 200 validators or so. And I think this is one of the main sort of philosophical differences between Avail and Celestia, where Celestia is built on Tendermint and has this constraint, but instant finality, and Avail uses this this probabilistic consensus mechanism. I'm curious what impact that has on the data availability sampling aspect of basically what you guys are building. Does it have any implications at all, or is it only just block production that is impacted?
Mhm. So, I mean, let me take it from two angles, right? Like, so one is of course the consensus part. The second is of the like the other, let's say the implementation differences between us and Celestia, right? Like the validity proofs and fraud proof differences, right? Like, so, in general, if you kind of take a look at the validity proof and fraud proof based differences, right? Like, so once you once the block is final on the base layer, um, the headers are propagated to the light clients, for example, and then like this whole random data sampling process flows, and essentially um, uh, that really the DAS verification really depends on whether on the type of proving system that you have, right? Like, so in a validity proof system, you can actually verify it instantly. On a fraud proof system, you have to wait in like a certain time interval. It might be the minutes or hours, for example. So from a application or a developer experience angle, right? Like, I mean, think of like a ZK rollup running on top of Avail and a ZK rollup running on Celestia, for example, right? Like, so the thing is that the for finality you have to wait for two things, right? Like, one is the DA finality, and then the proof, let's say the proof generation of the execution proof generation, right? Like, now it might happen that the execution proof has been generated, but you're still waiting for the DA fraud proof to be propagated, for example, right? Like, and so time to finality in that sense increases. Uh, in let's say this the same construction with the ZK rollup on Avail, right? Like, I mean, as because our construction really uses fraud validity proofs, right? Like, it's as soon as the block is finalized. And of course, we have deterministic finality, but in most of the cases, finality happens within a couple of blocks. Like, so essentially, in the majority of use cases, you'll be able to kind of get DA finality, and like in the case of a ZK rollup, like you don't have to wait around for that, right? Like, so those are the more philosophical differences. Yeah. And to zoom out a bit on the other side, right? Like, I mean, it's primarily about what is this role of a dataability layer or a base layer as we see it, right? Like, so today, if you see, Ethereum is the most dominant data availability player in that sense from a modular perspective. Of course, all blockchains have a data availability component, even like Cosmos blockchain, Solana, etc. have it embedded within their stack. But like from a modular perspective, Ethereum is actually the most dominant data availability provider to rollups on top, right? Like that's the thing today. And if you really want to kind of provide a compelling alternative to Ethereum in that respect, right? Like you also need to be a very decentralized, like secure layer, right? Like, and so if you want to really get into that um, that kind of positioning, like you have to think about these things, right? Like it, because it's very easy to get into situation where like especially using Tendermint, that like 8 of the top 10 validators or 8 or 10 of the top validators really control 67% of the stake, right? Like, and so for a base layer to have that kind of mechanics, it's risky, dangerous. Like it's not the best situation, right? Like, and that's why we consciously took this approach to kind of be closer to the Ethereum philosophy rather than the Cosmos philosophy, right? Like the Cosmos philosophy, in at least in my opinion, makes sense in a more application specific chain perspective. But if you are really trying to provide a more shared security kind of a product, then like the Ethereum philosophy matters more in that sense. Um, See, having said that, there are of course pros and cons, right? Like Ethereum has like this ability to onboard like hundreds of thousands of validators, like 100,000 or like more maybe, right? Like, but the problem is that like there is a limit to communication complexity that a network can manage, right? Like, and so now there are discussions within the Ethereum community also to increase the 32 ETH, like deposit limit for staking to I think to 2048 or something like that. So because they want to ensure that, because see, the reality of what is happening is the people who want to stake a lot of ETH really end up running redundant validator nodes.
Yeah, yeah.
And so essentially increasing the traffic on the P2P traffic on the network, right? Like, and so there is a proposal which is under active discussion to increase the deposit limit to 2048 ETH, so that it just reduces the validator number. And so I think the answer is somewhere in the middle, right? Like, I mean, Polkadot, made a lot of good choices on some of this, right? Like, I mean, it's not as low as, let's say, like a 30 or 100 kind of a figure. Although I won't say if 100 is a small figure, like it's a decent enough figure. But, like you don't want to be in the hundreds and thousands and then kind of try to scale back the number in that sense, right? Like, so we thought 1,000 was a good enough number. And on top of it, if you kind of look at it from a NPOS kind of a implementation point of view, like how many unique validators are really running your network, right? Like that is also an important metric. Like people like to call it the Nakamoto coefficient and so on. But even that is important, right? Like you can't have the same validators running too many multiple nodes, right? Like, so what are the levers that you can employ? Uh, and so this is like a broader question, right? Like, I mean, Ethereum is grappling with, let's say, things like, like Lido, like, and, like Ethereum restaking and, like those sort of things, right? Like, so at some point in time, we will also, like get into those kind of questions. And we really wanted to start off with the right foundational levers, to kind of like solve this, right? Like otherwise like changing some production network in between, like changing the things like the consensus is like it's a very big move for a network, right? Like
Yeah.
and so yeah, hopefully I was able to answer some of your questions.
Yeah, no, that all makes sense, and I think really clears that up. So, but yeah, let's talk about the data availability sampling then. Maybe we've talked about DA sampling on the podcast before, but maybe let's just unpack that and remind our listeners like what that means and how applications use it to in order to prove that their data has been essentially added to a block without having to add the entirety of the data, because that's one of the things that platforms like Avail are, that's where they're different from like Ethereum, for instance, where like all the transaction data is on chain. Avail only stores the hashes of the data. So yeah, maybe explain DA sampling.
Yeah, yeah. No, so let me just also correct you a bit, right? Like, so in general, Avail
So
stores the entire
even I got it
transaction
wrong.
data.
So we need an explanation.
Yeah, yeah. So, I mean, see, I think just zooming out a little bit from your question to answer this, right? Like, so essentially, like what really goes on in a blockchain is that, like what you really need to know is the correct order of the transactions, uh, um, and basically the fork choice rule, and then you need, like the execution validity. So in a conventional blockchain network, let's say like a Cosmos blockchain, right? Like, so there might be like 100 validators, there might be like few hundred nodes, full nodes, for example, and so on, right? Like, so what the validators are really doing is, like they're getting the transactions, and they're, like, let's say in Cosmos, for example, there's a block builder which will kind of order those transactions into a block, and then each validator will re-execute those transactions, and then the 2 by 3 of the validators, or 2 by 3 plus of the validators, will reach an understanding that whether on the fork choice rule, right? Like, primarily, like which is the correct block or the correct order of transactions. And then the full nodes will, like listen to this. They will not trust the validators uh, with the validity, execution validity. They will download all the transactions, and then re-execute those transactions, and then they will arrive at the right state, for example, right? Like, so that's the rough, yeah, very rough flow in a conventional network. So now, if you want to put this in a more modular context, right? Like, what do you really want to have, right? Like, so in an Ethereum context, what is happening is, like there's this roll up on Ethereum which takes in transactions from users, and it's called a sequencer today because that's the component which orders those transactions, like which defines the order of those transactions. So, and then they commit to the order of transactions on Ethereum. Right? Like, they put the whole transaction data or the state diffs data on Ethereum, so that even if the sequencer now goes down, right? Like, anyone can take the state from Ethereum and arrive at the correct state because they can just re-execute those transactions. And now, so the different rollups differ in like how you can verify the execution, right? Like, so there are probably three types of these different transactions, right? Like pessimistic, optimistic, ZK. And so pessimistic is again, like take the order and re-execute those transactions again. Optimistic, it is that some people will look, re-execute those transactions, and if there's a problem, then they will raise a fraud proof, for example. And, like a ZK roll-up or validity proof thing is that there's a prover that provides a mathematical proof, and you just have to verify the proof, right? Like, so now, like, just to like give the entire picture, right? Like, there is this whole ordering piece, and then there is this execution piece. Now, naively, if you want to look at it, you will download all the transactions, and re-execute all the transactions. That's what happens in a conventional blockchain network. Now the question is, how do we make this process more efficient for users, or like just in general stakeholders? Now, in Ethereum, for example, today you will have to download all the transactions to get a full dataability guarantee, and this happens in any POS style network, right? Like, the main innovation that Avail brings to the table is efficient way to do this data availability verification. Like, you don't have to download the entire data. The entire data is there on Avail, for sure, right? Like, Avail certainly stores all the data in the ordered format. Now, but you don't really need to run a full node and download all the data and then verify data availability. This data availability sampling thing, it employs this clever mathematical trick of erasure coding and KZG polynomial commitments in our case, to enable data availability sampling, where essentially you are kind of, so this is like, just to simplify this, right? Like, erasure coding is this technology that is used in, has been historically used in, things like storage, like, like on a compact disk, for example. if you remember, if your listeners remember compact discs, is that like you can you can have a compact disk or a hard disk, for example, and like maybe there are some scratches on the compact disk, and but you want to ensure that no data is lost. So what compact disk manufacturers do is erasure code the data on the compact disk so that it is replicated and in randomly in such a way that like even if there's a scratch on the compact disk, even if one data fragment is lost, you are like it's very easy to ensure that the a replicated fragment is available somewhere else on the compact disk, right? Like that's erasure coding, roughly, right? Like, and so essentially what this allows is for these light clients to verify this data availability very succinctly. Like within a few samples, they're able to kind of verify up to 99.99% probability that the data is available, right? Like, and so that's one part of it. The other part of it comes from the more execution focused verification, which is like let's say ZK proof, ZK rollup, right? Like essentially you don't have to re-execute all the transactions, right? Like you just verify the proof of the transactions. So what I'm trying to arrive at is that this unique combination of DAS, which gives us very efficient DA verification and more succinct execution verification. So the ZK rollups are the most easiest to verify, but optimistic rollups, like are not far behind, right? Like I mean, in the sense that not everyone wants to do it, someone will do it, and you optimistically know that the execution is correct, right? Like, and then so again, pros and cons in both these. But so essentially, this is what I'm trying to kind of convey that like you have to look at it from an entire angle, and that's what really data availability sampling it kind of brings the ease of data availability verification, and when you combine it with execution verification, it becomes very very powerful. And that's why we always talk about Avail more like an enabler for these newer kind of rollups. For example, of course, it will support existing kind of rollup constructions, but like you can do entirely new kind of rollups with this kind of architecture. Again, last point really quickly, I just wanted to cover there was because we've been building this data availability sampling technology, right? Like so, what this really these are these light clients which do like these random sampling, and we have kind of used something called Cademlia DHT to implement this on the light client layer. And essentially, you can like just to simplify things. This is you can think of this like a bit torrent kind of scheme. It's not the same, but to visualize, it's a useful analogy in the sense that you kind of put the data into Avail, the transaction data from rollups onto Avail. After it gets finalized, it slowly gets randomly sampled by the light clients, and also fragments of those the data also gets stored on the light clients on the Cademlia DHT. The DHT is a distributed hash table, and so any new light client that comes into this network doesn't really need to rely on a full node or the validators to get this data. It is actually available of like a light of a light client that has already sampled some data, for example. And so by the dint of this, what we had to really build was a very comprehensive P2P network, actually, to kind of enable that like stuff doesn't get overloaded, and it's pretty efficient. And that will also serve as the foundational layer for this more execution verifier propagation, right? Like, I mean, in the sense that you can actually now take the light client, which is a verifier for DA. You can take the execution verifiers, which is let's say like a recursive proof verifier, and then embed this into wallets, for example, right? Like, and so the combination of this is extremely powerful. Again, sorry, long-winded answer, but I just wanted to ensure that like I cover all the angles.
Yeah, no, that's really interesting. And so, um, like, what are the like? If I was reading on your on the blog that you guys are like, there's this interesting research about increasing the block size. So I think
Mhm.
like right now the erasure coding is like 256 rows by 256 columns, and there's some particular trade-offs when you want to increase the block size. Can you talk about like what the trade-offs are and what is that basically dependent on? Are we depending on like better network connections in order for like blocks to propagate faster? Is it more so like being able to validate those blocks, so when validators run the transactions, or is it the erasure coding that then takes longer? Like what are we kind of dealing with in terms of
Yeah, yeah.
scaling here?
No, I think that's a good question to ask in that sense. So, like, what changes when we actually see why are we again building Avail as a separate like a layer that focuses on one aspect, the data availability aspect or the consistent ordering aspect, right? Like, I mean, why are we focusing on that? Because when you decouple execution from, let's say, the data availability or the consensus and ordering layer, what now happens is that we don't really have this, like issue of maintaining state on Avail, for example, right? Like we don't have to maintain execution state, and that really allows us to increase block sizes pretty rapidly. Um, so the alternate approach to this is like, let's say, like a more sharding sort of an approach, for example. But really, in this kind of construction, we don't really need to shard, right? Like we can just increase the block size, and it's very different from increasing block sizes on, let's say, on execution-focused blockchains. Like we had this whole block size scaling debates and wars on execution-focused blockchains, right? Like, and it is not practical there because you just increase the requirements of, like let's say full nodes and validator nodes and such. In this specialized, like construction which Avail employs, right? Like we can increase block sizes pretty rapidly. Like we have benchmark sizes of up to 128 MB, and it can go even beyond, right? Like I mean, because we have this very neat construction of erasure coding and polynomial commitment generation. Um, Now, okay, what happens when we actually increase the block size, right? Like in that sense, is that like of course the time to generate the commitments on our blocks. So we have these polynomial commitments that we create and we add it to the header. So like mathematically, you can think of this like a m cross n matrix. We erase code the matrix to make it 2m cross n, and then we do commitments for the rows, for example. So if you increase the size of the block, we are really increasing the size of the matrix. And so the number of rows increases, for example. And so the commitments that we have to generate also increase, for example, and so on, right? Like, but essentially, like the polynomial commitment process or the modules that we use, right? Like these are not really, like, so you can't compare this to something like an EVM, ZK EVM prover, for example. These just very simple circuits that kind of generate the polynomial commitment, right? Like, and these are pretty. We have been, kind of working on iterations, and these have become more performant over time, right? Like, so for example, for a 2 MB block, these commitment are generated within milliseconds. For 128 MB blocks, these will take a couple of seconds, for example. But because we are this, kind of base layer, we don't really handle execution. We don't really need to have like extra fast block times, right? Like because the extra fast block times are on the execution side, on the rollup side, on the sequencer side. So that's why we have the capacity to actually increase the block size even without increasing, like keeping within the constraints of the block time that we have set for ourselves, right? Like, so those are some of the trade-offs that we have to make. Um, in general, because we stick to this validity proof approach, and we generate these commitments within like very quickly, we can propagate this, like proofs can be generated for these commitments pretty rapidly, and then like they can be verified pretty quickly. So that's the beauty of having this different sort of data availability focused layer, so to speak. I may be missing some of your questions, but hopefully I've answered some of them. But just feel free to remind me of
Yeah, no,
any specific.
that covers it. So I want to get into the economics of Avail a little bit. So like for an application, when thinking about the monolithic stack, when you're building an app on Ethereum, like your cost structure is pretty easy to sort of reason about, right? You have to pay Ethereum for block space, or even users of your application pay Ethereum for block space unless you're subsidizing that somehow. in the modular stack, depending on the say the roll up as a service that you're using, maybe you don't have full sovereignty over the sequencers, the settlement layer, and certainly the DA layer. You're sort of like choosing an underlying stack based on your kind of execution layer provider. How do developers have to reason about this, and how will, because essentially, like, I think the competition will be on price. It like competition will come down to like all of the layers of the stack constructed together in like in a stack, right? So if you're building an application that is on a roll up as a service provider, and that service provider is using Celestia or Ethereum or Avail, you're sort of beholden to that whole stack and their cost structure in order to figure out what the cost of your application will be. Is that the right way to think about it? And then what do you anticipate the cost of running an application will be first compared to monolithic L1s today? Do you think that the modular stack will reduce the cost of running applications overall?
Yeah, no, I think again, good questions to ask, right? Like, so I think you are certainly right. Like that cost will be a factor. At least I would anticipate in the initial short to medium term is what we anticipate, right? Like that's how we are looking at it from that point of view. Certainly, cost will be the driving factor initially. We expect that this will be augmented with, like us enabling newer sort of roll-up constructions, for example, where like you have settlement happening client side, for example, and like a host of newer roll-up constructions that can happen, right? Like more like let's say sovereign roll-ups and such, right? Like, but we'll not get there at the moment, right? Like essentially initially, like I think, like I kind of like to use this analogy of like cars and wheels for now, that like roll-ups are really like the car manufacturers, and we are like the wheel manufacturers, right? We are like the OEMs on the on the cars, right? Like, and so essentially our GTM primarily is for like to like partner with, let's say, cars to ensure that like their cars go out with our wheels, for example, right? Like, and so essentially um, um, the cost structure also kind of like reflects that in that sense, right? Like, so in general, of course, the sum of the costs of each layer will be exposed to the application developer. uh, Today, because there is like let's say less DA capacity on, let's say, something like Ethereum, costs are pretty high. Ethereum price itself plays a big role also. So in general, we did some modeling on the cost structures, and like over the last few months, the average price of DA on Ethereum is about $13 per MB, $1,300 per MB of data. This is based on actual,
$1,300 per megabyte.
yes, $1,300 per
Oh.
megabyte, roughly. Of course, there's you know spikes in ETH price and usage and such, whatever is paid, but the rough price is around $1,300 per MB of data, right? Like, I mean, essentially, the trick for us is to, because we have this whole increasing data, like scaling data capability because of like our construction, we are able to kind of like, of course, bring costs down because we have more DA capacity, right? Like that is certainly, and but we also have to ensure that we are sustainable. Our validators have to be profitable, for example. We need to have a wide enough validator set, for example. So we have to be, essentially, we will be more costly than, let's say, like a data availability committee, for example, which is like like run by 5 or 6 7 data members, right? Like, so initially there is this whole cost game that will come into picture, which will like kind of play into the actual application developer cost, right? Like, so you can see right now, let's say like an Arbitrum runs on one chain, it also runs on Nova chain, for example. Starkware is planning a volition mode where it'll you can run in rollup mode or in validium mode, right? Like all of these the Nova solution and the Validium solution right now employ a DAC, for example, right? Like so the cars or the L2s, for example, have really literally already made the choice to like kind of use layers other than Ethereum for some of their offerings, right? Like and so essentially, what we think is, of course, we'll be from a cost perspective competitive, very competitive against, let's say, like a Ethereum, but like maybe more than a DAC, for example, in that sense, because we offer different characteristics of decentralization and security and such. For example, um, if you want to compare it to, like, say, like monolithic L1 chains, right? Like, so what really differentiates is it just in general the sheer variety of execution environments that are really going to come in the next 6 to 12 months, right? Like, I mean, because with this, we are able to kind of support a variety of execution environments, which, bring a different sort of trade-offs for application developers. So it's a combination of this, right? Like the costs, we will have to, of course, play as per the market, how the market goes. We have to ensure our validators are profitable, and then we have to ensure that, like kind of applicant developers get a good deal. So it's somewhere in, like that takes care of all this. Um, Hopefully that answers your question.
Yeah, that's interesting. I mean, and I hadn't heard that figure of $1,300 per megabyte. It seems like so incredibly high. I mean, I know this doesn't really compare, but if you compare it to something like Arweave, I think the cost per gigabyte is like less than $100 or something, right? It's like $50 a gigabyte for what the, about eternity apparently. Um, so yeah, I don't like
Yeah, I mean,
that
see,
seems
basically,
crazy
of
high.
course, that same metric, like the data is very different. Like, let's say, like in what an RV and a Filecoin really store, right? Like, I mean, so here the product being sold is, like ordering consensus and ordering, like data availability is really not data storage in that sense, right? Like
Yeah, yeah.
it's basically a, uh, uh, which is the correct ordered set of transactions, and so technically it is very different from, like a RV or a Filecoin, and this is the only reason why, so Ethereum is the only, I mean, not the only player, but because each L1 maintains its own data availability, and so there's a cost to that as well, for example. But it's the only player that has, like where rollups are there right now, and it is providing DA separately, at cost, like at some cost
Yeah.
to, like customers on top, right? Like, and so that's the reference that we have, and $1,300 is right now where ETH is, like at not that higher price for now, right? Like, I mean, it certainly goes higher. Like if you get to data from last year, for example, or the
Yeah.
year before, right? Like so essentially, certainly, that's the main reason, right? Like, I mean, see, there is a price for this product, like, and the current, so I don't really want to directly compare these solutions, but what I'm trying to say is that Ethereum certainly charges a very high fee at the moment. With its upgrades, it will come lower, but there is still a wide range of costs that you can actually maintain and still be profitable, right? Like, and so there's enough space for, like Avail, for example, and even Celestia, for example, to come in and, like operate at, like in this market. And right now, very frankly, there are not too many players in the market. Uh,
Yeah, yeah. Cool. Well, I'd love to ask you more questions. Like I've got so many more questions here, but I know we're running a little long here. But I want to ask you like one final question about basically what's the state of Avail currently. I know you guys have a test net. What's the roadmap and some like major milestones that people should expect, and yeah, maybe ending on like what are the biggest challenges that the project still faces before mainnet.
yeah. So essentially, I would say, so we are slightly in a different we are a different kind of company in the sense that like we were started initiated within Polygon, and so we have been actually been in development for close to like 2.5 3 years now, and so we are actually very near mainnet. So in the sense that our second testnet is like now concluding. Our final incentivized testnet is starting in the end of October or first week of November. It'll probably run for a couple of months. I think it's Christmas season, so things will be slow over the holidays. But I think January is when we'll conclude that, and our final audits are finishing pretty soon by the end of the year. And hopefully, like we are pretty much code complete, right? Like from a mainnet release point of view. So we are just waiting for things like incentivized testnet first issues to occur come up there, for example, or on the final audits, for example. But otherwise, like we are very we kind of are ready for like a Q1 2024 mainnet launch. Um, so from a development stage, like we are actually very near production. Our bridge from Avail to Ethereum is also expected to finish by December, for example. We already have an optimistic bridge. We are working on a ZK bridge with the Sasin Labs folks on that. And that is also like a major innovation there. In general, we've been busy building integrations to major rollup providers. We are going to introduce, at least three major um, Ethereum L2 rollup stack kind of integrations pretty soon. Others will hopefully follow pretty soon. So, like, I mean, it's now we are very much getting nearer to like a lot of rollups running on top of, like testnet initially, then on mainnet as well. We've like someone like a dimension like we dimension works pretty closely with us. They're running an incentivized testnet, and if you kind of look at their portal, there are literally hundreds of rollups running on the like Avail testnet, even like as we speak, for example. And
That's cool.
uh, yeah, and so I mean, I think we are pretty close to mainnet. So yeah, so we will be announcing some of this stuff pretty soon. Um, in terms of like problems, like I think uh, from a I think from a technical angle, solution, if I will, like if I might say, like Avail is one of the best stacks out there in terms of like the architecture, the implementation, for example. But in general, from a marketing angle, I will really readily admit that like we are behind the curve in terms of, let's say, Celestia, for example, which has done a great job of like kind of creating this whole data availability or modular category. And so we are kind of like in that follower positioning at the moment, right? Like, and I will readily admit to that. So that is, I think, the main problem with Avail at the moment, right? Like, because I would say a validity proof based approach to solving DA is the better approach, I would say, because like even if you look at Ethereum, they are really following the same sort of approach. They want to do it. And so we are really leading in implementation from that sense. But yeah, if you ask me one big problem that we have, this is that I would say that is the problem. And of course, we are looking to kind of solve it, and hopefully, like we'll get to that point. But yeah, I mean, mm, we'll take it one by one. We just want to kind of get to mainnet soon, and then like slowly we will solve those problems as well.
Yeah, well, maybe what you lack in marketing, you make up in branding and like technical writing. The Avail blog is like really good, and there's really excellent articles there. I'll link to it in the show notes, and I'd encourage anybody to that's interested in Avail to go check that out. Read some of the articles you have there, and yeah, this has been really fascinating. I've learned a lot about Avail and DA, and really looking forward to seeing Avail go to mainnet and yeah, compete in the space, because there's all sorts of interesting projects building in this space, and I think the modular stack is definitely not like codified. It's still very much in flux, and I expect that to happen in the next maybe 3 to 5 years, right, where we get a much better idea of like what the stack is looking like. And we didn't even talk about interoperability, which I think is a big component here, but we'll have to save that for another time. Anurag, thank you so much for making the time today and coming on the podcast and sharing all these great insights with us.
Yep. Yeah, thanks, Seb, for inviting me, and it was a great discussion.